Hi, good evening, everyone. Sorry for delay again because of some sound issues. Okay, we are trying to give, in fact, we are trying to improvise the situation, but I don't know what problem we are facing, right? Okay, so we will be discussing today again many things. You guys might have been waiting since morning, right? So say hi on the chat box, right? So that uh, my voice and all will be confirmed, right? So if my voice is audible, so please confirm once uh, on a chat box. Okay, before I start discussing some of the new concepts. So today the question of elimination will be done, right? आज हम लोग क्वेश्चन ऑफ एलिमिनेशन सीखेंगे, हाउ टू अप्लाई एलिमिनेशन ऑन मैट्रिसेस. Already we have seen how to apply elimination on system of linear equations, right? So just we will write system of linear equation and form the matrix and then try to apply the elimination. So please confirm once my voice is audible before I get started. Yes. So let me check also if you're not confirming. Okay, so yes, just I'm gonna confirm. Okay, yeah, it is fine. So guys, today we will be discussing about question of elimination, right? So let me minimize myself because okay, so just I'm gonna minimize myself now. Right, so the today's session will be on what? The elimination. Okay, we will try to solve the system of linear equation and how to apply elimination, how to solve basically any system of linear equation systematic using some systematic procedure, right? So this is one of the systematic way of solving, okay, system of linear equation. Okay, so these things you have to keep in mind. Already you know that how to apply elimination. If I give you 2 by 2 matrix, two equations if I give you, then you can apply elimination, deleting one variable at a time and finding other, then substituting back. So this has some name, Gauss elimination, right? We call Gauss elimination method, right? Gauss elimination method. Okay, this is one of the method to solve system of linear equation. There are other methods like Cramer rules is there, right? But this is one of the very important method which you have to always keep in mind. Okay, and whether you are solving system of linear equation or whether you are talking about eigenvectors. Okay, so in order to find eigenvector also you have to use elimination method, right? So Gauss elimination is one of the very important method that you have to keep in mind. So I will take some equations. Okay, we will be taking some equations and we will discuss some step by step procedure, right? So let me take 3 equations here. Okay, moving to next page here. So suppose we have got x1 plus x2 plus x3 equal to 4. Okay, and here we have got 2x1 plus 3x2, okay, plus x3 equal to 7, and we have got x, you can say x1 here, x1 plus 2x2, okay, plus 3x3 equal to 9. Okay, so in the exam these 3 equations will be given. Okay, the moment system of linear equations are given, okay, suppose this is first equation, this is second equation, and this is third equation. So what you can do, you can immediately write in terms of what the very first step is, what, write in terms of ax equal to b format. Okay, this is shorthand representation of system of linear equation. This is very first step which you have to follow. Yeah, hi Hers and hi Devans. Okay, so I believe you have noted down these things, right? So 3 equations will be given. Okay, 3 equations will be given, and first of all you have to write in terms of Ax equal to B. Okay, so we can quickly write in Ax equal to B. So from where we will get the matrix. So you can collect here the coefficient number 1 here. X1 has coefficient 1, this has 1, and this has 1, right? This is 2, this is 3, this is 1, 1, 2, 3. And here you write the vector, that is column vector x1, x2, x3, and the right hand side, that is 4, 7, 9. Okay, so I'm going to tell you the systematic procedure, right? So this is the very first step which you have to write. Now you should be only focusing on what? You should be only focusing on the matrix A, okay, and the matrix B. That's it. Okay. So the moment you will get system of linear equations, what you have to do, you have to write in terms of Ax equal to B, okay, the matrix A and the matrix B. Now the second step is what? You have to write, because you have to apply elimination now. Okay, see, you have to apply elimination. You want to delete, you want to make this this 2x and this we want to delete this, okay, 2x from here, right? And then we want to delete this x1 also from third equation, you can say, right? So that operation we have to apply on the matrix. Yesterday we have discussed about some elementary operations. Okay, we can multiply any scalar with any row, okay, and we can add or subtract any row, right, in order to eliminate that row, right? So what we will do here is, and as you can see here, we have got the matrix. So if you are going to apply all the operations on the matrix, so you are not going to get correct solution. So what you have to do here is, you have to take this guy also along with the matrix A, because you are not software, right? Software takes care of everything, but you have to take this B matrix and tack on the A matrix, right? So that matrix will be known as, you write here the matrix A, okay, 1 1 2 3 1, 1 1 2 3 1, right, and 1 2 3. And you write here the B matrix as well, because we are going to apply the operation on A and B as well, right? Okay, because B, you see here, right hand side is not 0. Okay, if right hand side is 0, then you don't have to worry about right hand side. Okay, but if right hand side is not 0, then you have to take also into consideration the right hand side while applying the elimination. See, 4 7 9, 4 7 9. And this matrix is known as, can somebody tell me what is the name of this matrix in the chat box? What is the name of this matrix? Everybody knows that. Okay, see, we have got the system of linear equation. Okay, the right hand side is not 0, right? We have written in terms of shorthand representation Ax equal to B. The matrix A is there. Now we are ready to apply elimination. Okay, so we have to tack on the B matrix on A matrix. So this matrix is known as A given B, or you can say that augmented matrix. Okay, augmented matrix. Sometimes augmented matrix will be given directly and you have to apply elimination. So what is the first step? The first step is Ax equal to B. Second step is what? A given B. If B right hand side is non-zero, right? If it is 0, then you don't have to worry about that. Okay, that is not the augmented matrix. Okay, this is the augmented matrix. Okay, yes, Devans. Now third is what? Very important point is, choose the pivot, the pivot variable. Choose the pivot variable. The third step is very important. And what is the meaning of pivot? Pivot is just a starting point, from where you can start applying elimination, right? Start applying elimination. Just I'm gonna choose some color here. Okay, so you see here, guys, just I'm gonna take this as a pivot. Okay, there is a criteria. Okay, which element can be taken as a pivot? Keep in mind this. The pivot should be non-zero. Okay, the pivot element should be non-zero. Pivot should be non-zero entry. Okay, remember that. Pivot is non-zero element, right? So I'm going to take 1 as a pivot. Okay, pivot, you can say pivot element, and What is the criteria next? What is the next step? You have to make below this pivot everything is 0. You have to make this 2 as 0, you have to make this 1 as 0, right? Okay, so how can you make this 2 as 0? See, you have to make this 2, and 2 is present in the row 2, right? So what you have to do, you have to apply row operation on R2. So you have to write R2 tending to, right? Okay, and R2 minus, you multiply with row 1, what? 2 times R1, right? So what you have to do, you just choose one pivot element, and below the pivot, the criteria is below the pivot all the elements should be 0. Left side of the pivot all the elements should be 0. So in this case, this pivot does not have anything left. Okay, there is no element in the left side. Okay, but down this pivot there are 2 elements, right? So you can apply this, and you have to also make this guy 0. So you can directly subtract, you can directly apply the row operation. R3, on R3 we are applying row operation. Now that's why I'm writing R3 here, and you have to write R3 minus R1. Okay, you don't have to multiply with any scalar constant because it is 1, and 1 minus 1 is 0. Cool. So now can we make that 0 here? You see, this is 1. Okay, pivot row should be same. You don't have to change anything because we are not applying any operation on pivot row. So this is 1, this is 1, this is 1, right? And this is 0 now, and this will be what? 3 minus 2, that is 1, right? This is 1 minus 2, that is minus 1. Okay, and this is 0, this will be 1, and this is 2. Same as here you have to apply 4, and now you multiply 2, 7 minus 8, that is minus 1. Okay, and this is what? 5. I believe till this point everything is clear, right? So what you have to do, given a system of linear equation, okay, you have to write in shorthand representation Ax equal to B. Then you have to take A matrix, take B matrix and join them. Okay, you have to just add extra column in the matrix A, that is known as augmented matrix, because number of column become number of column increases over there, right? Augmented. So then what you have to do, you have to choose one pivot. Okay, suppose this element is 0 here. Okay, the very first element of the first row is 0. Then what you can do, you can exchange row. Okay, nothing is going to happen, as I told you that exchanging row, swapping row, okay, interchanging row, or taking any equation as in, like first equation you can take as a third equation, or third equation you can take as a first equation. Nothing is going to happen. The value of x and y and z will be same. Okay, the variable value, whatever solution you will get, will be same always. Understood? Right. Now, for this pivot, okay, for this pivot column, you see here, this column, this column has one pivot now. Okay, now the job is over. You see, the condition is satisfied here. You see, below the pivot 0 0 0, left side the pivot there is no element, so we don't have to worry about that. Now you have to go diagonally, right? You have to go diagonally. Diagonally means principal diagonal. You take this as a pivot now. Okay, you take this as a pivot. Okay, so the matrix which you will get at the end, okay, there is some special name of that matrix. We will call that matrix as echelon form of the matrix, right? That is echelon form. Okay, so what is the meaning of echelon, we will understand, but please follow my procedure. Okay, systematic procedure. You see, you take 1. Okay, you take 1. Now what you have to do, see, left side 0 0, needless to worry about that. You have to make below this pivot the 0 element. Okay, this entry, this 1 should be 0. What you have to do, directly subtract it. So only one operation, R3 minus R2. Okay, so next matrix what you will get here is that, the matrix you will get here is that 1 1 1 0 1 minus 1. You don't have to change anything here. Okay, for wherever the pivots are there, you don't have to change any value, as it is you write. Now you are applying operation on third row. So this is 0, this is 0. and this will be what? You are subtracting directly, so this is 3 and this is 6. Till this point everything is okay, guys? Please confirm. Till this point everything is okay or not? Perfect. So you see here, how many pivots are there now? This is one pivot, this is one pivot. Okay. Now the next pivot you have to take as this. Okay. You see below this pivot, what should be there? Below this pivot, the non-zero, I mean 0 elements should be present, but no elements are there, right? So now your elimination is stopped here, right? And left side of the pivot, you see everything is 0 here. Okay. So how many pivots are there, guys? Can somebody count how many pivots are there in each column? In the matrix A there are 3 pivots. Yes, in the matrix A there are 3 pivots. Okay. So let me take this and let me take this, okay, this matrix from here. So I'm just going to write this matrix here. Okay. This matrix is basically 1 1 1 1, right? This is 1, this is 1, this is 1, 0 1 minus 1, 0 0 3, and this is 4 minus 1 6, 4 minus 1 6. Okay, 4 minus 1 6 here. Yes, it is perfect. So how many pivots are there? You count. Now you can count how many pivots are there. So one pivot is this, one pivot is this, and one pivot is this. Okay, understood, guys? So number of pivot, if somebody is going to ask you, what is the rank of the matrix A, so what he will say? Rank of the matrix, whatever you know in your language, right? The number of pivots, okay, in matrix A equal to 3. Number of pivots in matrix A equal to 3. And if I talk about number of pivots, you see here, number of pivots in augmented matrix is also what? You see 3 only, right? Because you see here, if you see, this is also non-zero, right? This is also non-zero. Okay, so number of pivots in the matrix A equal to 3. Okay, and so if somebody will ask you what is the rank of the matrix, so you can say directly that rank of the matrix A is 3. Okay, rank of the matrix A is 3. Directly you can say. So number of pivots is going to decide, the rank of the matrix. This is one of the very beautiful concepts nobody knows. One more thing. What is the main thing? Just I am going to tell you. See, if, note down this point is very important. If each column has a pivot, okay, then you will get what? Then you will get always unique solution. What? You will get always unique solution. Keep in mind this. Okay, why I am saying this? What is the meaning of number of column? Number of column decides the number of variable, or you can say number of unknown present in the system of linear equation. Yes, so each column has a pivot. You see here, column number 1 has one pivot, second pivot, third pivot, right? And there are 3 pivots, and how many unknowns are there? You get back to the equation. There are 3 unknowns. You see, x1, x2, x3, x1, x2, x3. Okay, so if each column has a pivot, it means you will get the unique solution. Okay, if each, remember this point is very important, and you can directly tell the rank of the matrix as well. The rank of a matrix A is equal to 3. Okay, why we are saying 3? Because there are 3 pivots. Okay, and the rank of the matrix A, or you can say each column has a pivot. Okay, which is equal to what? Which is equal to number of unknowns. So if number of unknown is equal to if number of unknown is equal to number of pivots, then you will get unique solution. You will get what? You will get unique solution. Okay, why you are getting unique solution? Three equations are there and three unknowns are there, right? So certainly you will get what? You can get whether if it is consistent, you will get two kind of solutions. Whether you will get unique solution or infinitely many solutions. Okay, when you will get infinitely many solutions? When suppose this row is entirely zero. If this row is entirely zero, okay, so how many pivots will be there? Yes, number of equations and number of unknown. Yeah, so that's why you can have two kind of solutions. One is unique solution or one is infinitely many solutions. But there is a condition, guys. See, we applied elimination and we got how many pivots variable? We got 3 pivots variable, which is equal to number of unknowns, okay, which is equal to number of unknowns. So keep in mind, if number of pivots are present in each column, right, and which is equal to number of unknown, okay, so you will get unique solution always. Understood? Unique solution you will get. Next, suppose this row, while applying elimination, this row would have been eliminated completely, complete zero, okay, then how many pivot variable will be there? You see, 1 pivot, 2 pivot. This cannot be taken as a pivot, guys. Let me give you the hint, the example. Suppose you have got 1 1 2 0 1 2 0 0 0 and this is 1 2 0. Okay, you got this kind of a matrix. Okay, so how many pivots are there, guys? Tell me. This is 1 pivot. This is after applying elimination. This is after applying elimination. Okay, we got, okay, after applying elimination, you can say after elimination. This is 1 pivot. Okay, we can take this as a pivot, but can you take this as a pivot, guys? Can you take this as a pivot? Comment in the comment box, in the chat box. Tell me first. We can't take this as a pivot. Remember, we can't take this as a pivot. Okay, we can't take this as a pivot. Remember. So how many pivots are there? Tell me now. How many pivots are there? There are 2 pivots. Okay, which entry can be taken as a pivot? The entry which is non-zero. Okay, the entry which is non-zero can be taken as a pivot in the principal diagonal. Okay, now, so how many pivots are there? There are 2 pivots. Okay, there are 2 pivots. So number of pivots, hashtag pivot means what? Number of pivot, you can say number of pivot. Number of pivot is equal to 2. And how many unknowns are there? Number of unknowns equal to 3. Okay, you don't have to worry about number of unknowns. See the column, how many columns are there in A matrix? There are 3 columns, right? There are 3 columns in A matrix. Okay, understood? So number of pivots are 3 and number of unknowns are, number of pivots are 2 and number of unknowns are 3. So can you have the unique solution, guys? Can you have the unique solution? Tell me. You can't have the unique solution. Remember this. You can't have the unique solution now. Okay. Can you have? We can't have unique solution. In this case, what will be there? We will be having infinitely many solutions. Okay, this is very important concept. Infinitely many solutions will be there. Understood? So the moment system of linear equation will be given, you have to start applying elimination. How? Take first as a pivot, make everything 0 by applying anything, any kind of operation you do. Okay, nothing is going to happen. Your solution will be same. Anyways, sir, we usually know number of unknown in the equation. Yeah, but number of unknowns, you know, that is equal to number of column, right? But there are situations. I will write 3 situations, okay, after elimination. You see here, I'm just going to write 3 situations. One is this 1 1 2 0 1 3 0 0 4, right? And this is 7 8 9. You can write. This is first, okay. You have to comment here. Next 1 1 2 0 1 3 0 0 0 7 8 9, right? One more situation I will write here. You see 1 2 3 0 1 3 0 0 0 7 8 9. Sorry, this is 0 also, okay. There are 3 situations now. Now comment here, guys, the very first, okay. This is after elimination, okay. I have told you how to apply. In the first case, how many pivots are there? Count. First pivot, second pivot, third pivot, okay. 3 equations, number of unknowns are 3, and pivots, each column has a pivot. Remember, each column has pivot, okay. Each column has a pivot. So what kind of solution you will get here? What kind of solution you will get? You will get unique solution in this case, okay. If each column has a pivot, you will get unique solution. Always keep in mind this. In this case, you see, how many pivots are there? 1 pivot, 2 pivots, okay. But the matrix A does not have, each column does not have a pivot. But you see here, the augmented matrix has 1 pivot, okay. This is one of the culprit here. Why? You see, if you are going to apply back substitution, right? Back substitution, okay. So this, what is it showing here is 0 equal to 9. Is it possible, guys? Tell me, is it possible? 0 equal to 9 is possible? No, it is not possible, okay. It is not consistent, guys, okay. So remember one hint I am giving you. One hint is there. What hint is there? Suppose here each column does not have a pivot, okay. Each column does not have a pivot. Number of pivots are 2 here. So rank of the matrix A is 2. Augmented matrix, you see here, right column has a pivot here. If a right column has a pivot, then what will happen? See, this row is completely 0. This row is completely 0. The matrix A has got row 0. But the right column, you see, this is right hand column, right? Rightmost column, you can say, rightmost column, right? Has a pivot. So what you will say? Inconsistent. Okay, in case of inconsistency, what kind of solution you will get? Tell me here. What kind of solution you will get if there is an inconsistency? If there is inconsistency in the equation, what kind of solution you will get, guys? Devans, you tell me, or Hers, you can comment here. If there is inconsistency, what kind of solution you will get? You see, number of, okay, if there is inconsistency, why? Because when you will apply, back substitution in order to find x3 equal to something, here you can apply back substitution. What? 4x3 equal to 9, okay. Then you can write this as x2 plus 3x3 equal to 8, okay. From here you find x3, you put back there, right? And then you can write x1 plus x2 plus 2x3 equal to 7. You can find x1, x2, x3, everything, okay, because it will give you unique solution. But in this case, what will happen? You see, if you apply back substitution, then 0 equal to non-zero. Is it possible? Tell me, is it possible? It is inconsistent, okay. The moment you see something is completely 0 and this side has a pivot, okay, you can't take this as a pivot, but you can take this as a pivot, right? So left to pivot, you see, so here you will get no solution, Okay, here you will get no solution. Okay, now in this situation, you see, in this case, very important, you don't know what is rank of the matrix, what is the meaning of rank and all. Okay, but if you know systematic way of applying elimination, then you can claim any question, right? Perfect. You take this as a pivot. Perfect. This as a pivot. Now this is 0 here. Okay, now right most column does not have a pivot. Yeah, fine. This row is completely 0. Okay, understood. So this is consistent. This is consistent. If it is consistent, then what kind of solution you can have? What kind of solution you can have, guys? Tell me. What kind of solution you can have? You can't have unique solution. Keep this in mind. Okay, you can't have unique solution. Why? Because each column does not have pivot. Each column does not have pivot. See, if each column has a pivot, then you will get unique solution. If system is balanced. Okay, see, when question will be given, you will be able to understand that whether system is balanced or not before applying elimination. You know, before you start solving the question, you can understand, yeah, the system is balanced. How? Number of equations should be equal to number of unknowns. Okay, then start attacking into the question. Okay, then you have to go for Gauss elimination, and the systematic procedure is this. Understood? Yes, 0 equal to 0 is there, right? Okay, so you will be having the consistency here, but you can't have unique solution. What you can have? You can have infinitely many solution in this case. Forget about what kind of solution you will get. I will discuss very soon. Okay, what kind of infinitely many solution you will get, but at least you can comment here that infinitely many solution. Infinitely many solutions. Okay, everybody understood till this point? So the moment you get the question, I have told you also, let me recap again. See, the moment you get the question, okay, first of all check if the number of equations are suppose m, and number of variables, suppose matrix has got m number of rows and n number of you can say, okay, you can say n number of unknowns, right, or column. So here you can have few situations. You can take m equal to n. In the exam they might give you m equal to n, means number of equations are equal to number of unknowns. Okay, so it is a balanced system. Balanced system. Okay, so if there is a balanced system, so three situations are possible, three kind of solutions are possible. You know, if you have to claim that what kind of solution you are going to get, guys, so there will be three situations. You know, so whether the system of linear equations are consistent and inconsistent. Okay, how to decide? See, if there are two equations, you can quickly decide consistency and consistency. But there are three equations, four equations, five equations. Then you have to write augmented matrix first. Then you have to reduce it to echelon form. Okay, echelon form means what? Just I am going to come. Okay, talk about that. This is in echelon form only. You see, echelon is nothing but your entries are in staircase. Okay, structure now. See, you have reduced your matrix A to staircase structure. And staircase structure, if your numbers are arranged in staircase structure, it is known as echelon form. Staircase, keep in mind. You see, there is a stair. You see, okay. You see, the AIR 1 is sitting there, then AIR 2, then AIR 3. That is what? Echelon form. Okay. Now, so consistent. If something is consistent, so you can have two kind of situations, right? Okay. Unique solution okay, or infinitely many. Infinitely many. Understood, everybody? See, when you will get unique solution, okay, unique solution you will get when each column has pivot. Okay, I believe this is fine. If number of pivots are less than number of unknowns, then you will get infinitely many solutions. Okay, now the situation is next situation. You can have either m greater than n, or you can have m less than n. M greater than m less than n. See, in this case you can say no solution. Just be blind, guys. No solution means no solution. You don't have to waste your time. Don't break your head. Don't break your head, guys. Okay, if m is greater than n, what is the meaning of this? Number of equations are greater than number of unknowns. Number of equations are greater than number of unknowns. Okay, in this case what is there? Number of equations are less than number of unknowns, or you can say number of rows are less than number of columns. Number of columns are 3, number of rows are 2. In this case, what is this? Number of equations are greater than number of unknowns. Okay, yeah, less equations and unknowns are more. Understood? So, okay, so in this case you will get two situations only: the consistency and inconsistent. Okay, and inconsistent means no solution, and if the situation is consistent, what is the meaning of consistent? Consistent here will be what? Keep in mind this. You cannot have, remember guys, number of equation is what? Number of equation is always keep this in mind. This is very important concept. Okay, number of equation is less than number of unknowns, so you can't get unique solution. Okay, or you will always get what? Infinitely many solutions. I believe this is fine for everyone. Yes, clear? Infinitely many solutions you will get. Why? Because number of equations are less than means number of equations are less what? 2 equations and 2 unknowns. 2 equations and 2 unknowns. Okay, 2 equations and 2 unknowns. So you will get. Okay, so I can take some questions as well. I don't have any problem, right? So I'll take questions. Okay, and I will show you directly. Okay. So 2 equations and 3 unknowns, right? So you will never get unique solution. That please keep in mind always. 4 options will be given. You can eliminate one option. Unique solution is not possible. Okay, unique solution is not possible. I will take one question and you will understand that. It was asked in GATE 2022. Okay, in electronics and communication branch only. Okay, so I'll take that question very quickly, and that was very good question. Understand? Yes. These are very basic concepts. Okay, very basic concepts are there, and which you have to always keep in mind. Next. Yes. So till this point, any doubt is there? Please let me know. Okay. So number of equations are less than number of unknowns. Okay. If number of rows are less than number of columns are more number of, okay, you can say rectangular matrix is there, okay, is you are not getting square matrix. If there is a square matrix, okay, keep in mind this, if there is square matrix is what, number of equation, number of unknown, or you can say number of row is equal to number of column, right? From the school days we know this, number of row equal to number of column, but in our engineering time, okay, like if you are an engineer, so you should think like that, okay? So this is very, very important to understand, right? So I'm just going to take that question in this okay session, so that you can take a look and let me know which okay, I'm just going to take this question here. You see this question, I hope this question is on your screen. Can you try this question? What is the situation? Which option we can eliminate quickly? Tell me here. Yes, yes, Devans, we are coming to, okay. So try to look at this question first, okay. How many, yes, what kind of equation is this? What kind of situation is given here? Tell me here. Ax equal to b is the system of linear equations, okay. That is a shorthand representation. The matrix A is given, the matrix B is given, okay. How many equations are there? How many unknowns are there? Which option we can eliminate first? Tell me. Which option we can eliminate? Which option we can eliminate? Tell me here. See, option A can be directly eliminated, guys. Okay, you don't have to check anything. Option A is not correct. Why? Because number of equations are less than number of unknowns. There are 3 columns, okay, and there are 2 rows. Understood? And this cannot be correct option, this, because here you see exactly 2 solutions they are saying. It means what? Okay, it is just like a unique solution only, right? One more solution is there. But in case of while solving the system of linear equation, because of a straight line or something, you know, we can have always infinitely many solutions or unique solutions. When 2 equations or 2 planes are intersecting, 2 lines are meeting at a point, unique solution, right? So these 2 options you have directly eliminated. Now the question is, between B and C, which one is correct? So what you have to do, the very first step is, you have got A, you have got B as well. So you write here 1 minus 2 3 minus 1 root 2 minus 3 1 3. Okay, now the question is, you will get 2 kind of solutions here. Whether you can get no solution or infinitely many solutions, right? Okay. So when you will get no solution, you will get no solution only when the system is inconsistent, and I believe this system is inconsistent. How? Apply elimination here. Apply elimination. How to apply elimination, guys? Everybody knows how to apply elimination. You see, you take this guy, okay, you take this guy as, now make the below entry, below element as 0. So what kind of operation you will apply? R2 plus R1. You just add these 2 rows, okay. So I'm just going to add it. 1 minus 2 3. This is 0 because 1 minus 1 0. This is also 0. This is also 0. And this is what? This is 4. Okay. Is it consistent, Devans? By looking at this, is it consistent? You see? See, the matrix A has 1 row completely 0. How many columns, how many pivots are there? You see, 1 pivot is there, and rightmost column has a pivot as well in the augmented matrix. Okay, if it has also 1 more pivot, you see, okay, but this is completely 0 and this is non-zero. Okay, so which option is correct? Pivot is 1 in this equation, but rightmost column has pivot, so no solution. Yes, it is inconsistent. Okay, if it is completely 0, suppose this equation is would have been like this. Suppose, let's see, 1 minus 2 3 0 0 0 and 1 0, like this. Okay, then you will get option B. But in this case, as per question, it is inconsistent. Then what will happen? No solution. You don't have to waste time, guys. You don't have to waste time. Okay, because in this question only you have to investigate whether these given matrix, these given system of linear equation has solution or not. That's it. They are not looking for the kind of solution. Okay, like what is the, suppose you got unique solution, though in this case you cannot get unique solution, so never try for unique solution. Okay, I hope this makes sense for everyone. Yeah, perfect. So this is what the situation is I wanted to discuss. Okay, and in this case this is very beautiful. Okay, in this case you have to again check consistency and inconsistency. So in this case, what number of equations are greater than number of unknowns. Okay, so if m is greater than n, I am talking about this, m is greater than n, so here you can get unique solution. It is possible. Let me give you some situations here. Suppose this is like this: alpha, beta, gamma, a, b, c, or just take some other variable for this situation: a, b, c, d, e, f. Okay, if this is a situation, now how many equations are there? One equation, two equations, three equations, right? Like this: ax plus b by equal to 1, cx plus d by equal to 2, and ex plus fy equal to 3. Right? So you have to immediately write augmented matrix. So it is a, b, c, d, e, f. Come on, 1, 2, 3. Okay, now you have to apply elimination. Let's say we are applying elimination. Okay, and we got some form, right? In these kind of forms we have got a, b, because you have taken this as a pivot and you made this completely 0, and this is 0, and this is something, like you can say some unknown. Okay, x, and this is 0, this is 0, right? Okay, and you see here this is 1, this is 2, and this is also 0. Okay, so how many pivots are there, guys? Tell me, how many pivots are there? Tell me, how many pivots are there? How many pivots are there? You have to decide. You see how many pivots are there. I am just telling you. This column has a pivot, perfect. This column has a pivot, perfect. So here number of pivots is equal to number of unknown. If number of pivots is equal to number of unknown, guys, then you will get unique solution. Okay, because by default in the equation itself there are how many unknowns are there? There are two unknowns, right? Because two columns are there, c1 and c2, r1, r2, r3. Okay, so you will get unique solutions in this case. Understood? When you will get infinitely many solutions, see, or when you will get no solution. Suppose this we have got like this. So keep this in mind. This is very important. This kind of situation comes. Suppose you have got a, b, 0, 0, 0, 0, and c, 0, 0. Okay, what you will get? What kind of solution here you will get? How many solutions? Okay, you see, number of pivots are 1 and number of variable is what? Number of pivots are less than number of variables. So you will get infinitely many solutions. And when it will be inconsistent, suppose you have got like this a b c d 0 0 1 2 0, sorry 1 2 3 here. What is this? Tell me. How many pivots are there? Two pivots. Fine. Perfect. But something is inconsistent here, you see. Something is inconsistent. Okay. So no solution. I believe this is fine. So Devans is saying you have retracted your okay comment. Whatever you are writing, it's fine. Just keep your comment alive so that others learner will be happy to learn from you, right? Whatever you are writing, whatever your experience while live sessions. Okay. So guys, this is what I wanted to discuss for today. There are many questions which you can start trying. Okay, understood. So you can start trying to solve. So you can try PYQ now. Okay, you can start solving PYQ. I will discuss the basics of matrices. Okay, basics of matrices we have to discuss, like matrix algebra, how to multiply. This was just all about introduction. Okay, and this is how we have to study, where no confusion should exist. Okay, and we have discussed about pivots. Okay, suppose any column does not have a pivot, right? Then what? Okay, then what variable, what is the name of that variable? That you should know. That variable is known as free variable. Okay, what I mean to say here is that suppose 1 2 3 0 4 5 0 0 6 7 8 9. Okay, fine. Now let me remove this guy. It is 0. So you don't have to discuss anything here. It is inconsistent. No solution you will get. But suppose this guy is 0. So you will get infinitely many solutions, right? So the column which has got a pivot, okay, the column which has got pivot, okay, variable, you can say this is one variable, this is one variable. Two pivots are there. So these variables are known as, this is, you can say x1, and this will correspond to x2, and this will correspond to x3, right? So x1 and x2 are known as, we call it dependent variable. Dependent variable, right? But this guy, this, here third column does not have a pivot, but this, what is the name of this variable? Let's name it. Okay, it is a newborn guy. Okay, so if somebody is born today, so you have to name it, right? What is the name of this guy? This guy name is free variable. He can take any value. We will say x3 equal to alpha. Okay, if x3 equal to alpha, then what is the value of x2? So from here only we can write here, see, 4x2 plus 5x3 equal to 8. So you can find 4x2 plus 5 alpha equal to 8. So 4x2 equal to 8 minus 5 alpha. x2 equal to what? 2 minus 5 by 4 alpha. Yes. So you can find x2, and now you can find also x3. Okay, but in this case you will not get unique solution. Okay, you will get infinitely many solutions. So what is the form of infinitely many solution? Many people have lot of confusion. Infinitely many solutions. Infinitely many solutions. Okay, so any system of linear equation, let me tell you guys, any system of linear equation will be given. So it will be having two solution always, right? I mean, solution will be having two parts. Okay, so the complete solution, right? Remember, complete solution, okay, when right hand side is non-zero, means I'm talking about complete solution of non-homogeneous system of linear equation. Complete solution of non-homogeneous system of linear equation. Okay, suppose x is the solution, so it will be having the particular solution, it will be having the homogeneous solution. Okay, it is very important concept, just like when you solve the differential equation. Okay, Devans, which one please explain m less than n portion again. Yeah, sure. Okay, so you see what I am trying to say here is, whenever you try to solve, differential equation, right, you have got two parts of the solution. One is the complementary, CF, and one is the particular integral. In this case also, whenever complete solution of the nonlinear system of linear equation you are solving and you want to get complete solutions, you will always get particular solution, you will always get homogeneous system of linear equation solution. XH, H means homogeneous, P means particular. Now, how can you identify that which one is homogeneous solution and which one is particular solution? That is also very important to understand. Okay, so I will discuss these things. Okay, I will discuss these things. Keep in mind this. Here you have got x2. Okay, and I hope you understood the concept of free variable. Wherever the pivots are not present, wherever pivots variable is not present in the column, you take that column as a, unknown as a free variable. Here this column has a pivot, so we take x1 and x2 as dependent variable, and free variable is alpha, right? And also you can find the number of free variable equal to number of unknowns minus number of pivots. Okay, so number of unknowns are 3 here and number of pivot is 2, so we will say number of free variable you will get is 1, right? This is how we can find out, right? And number of free variable is also is equal to nullity. You might be knowing the meaning of nullity. Okay, we will discuss. Okay, number of free variable equal to what? Unknown minus pivots. Okay, so we'll discuss beyond this. This is not complete. Okay, we have got x1, x2, x3, but further we have to go ahead and write in proper format. Okay, that format is very important, because this year in 2023 questions were there, right, and many students got confused. Okay, in this format we have to write, and we will understand what is the meaning of xp, we will understand what is the meaning of xh. Now, coming to the doubt of demands, m greater than n, number of equations, okay, are greater than number of unknowns. You can say there are more number of alpha, beta, a, b, c, d, right, like this. So here 3 rows are there and it is 3 by 2 matrix, and m less than n means what? Number of equations are less than number of unknowns, means 1, 2, 3, 4, 5, 6, like this. Okay. Here 2 by 3, rectangular matrix, it is a rectangular matrix. Okay, see, if there is no balanced system is what? Square matrix you should get. Okay, the matrix A, whatever you are getting from system of linear equation should be square matrix, then only that is balanced. Okay, in that case 3 situations will be there. I mean, first of all you have to check, and when you have to check whether it is consistent, inconsistent. See, if there are 2 equations you can check easily, right? 2 unknown, 2 equations, just by directly subtracting or adding. But if there are 3 equations, you have to write, you have to go for systematic procedure. You have to reduce it to echelon form. Okay, I mean, apply elimination, then okay, once you make it everything 0, right, below the pivot variables, right, and see, then by looking at that you can, if there is, see, one more thing, if there is no free variable, it means you will get unique solution. Understood? If there is a free variable, you will not get unique solution, you will get infinitely many solutions, because free variable can take any value. Understood? So this is also one of the hint I am giving you. Okay, next. So this is very, very important. So in this case you can only get what? If the equation is consistent, when you have to check consistency, after reducing to echelon form. Not, the moment you see, you can get, right? Just take this guy as a pivot and apply row operation. You have to make it 0. How can you make it 0? R2, you have to apply R2 minus 4 times of R1, right? Then only this guy will become 0, because 4 times of R1, 4 minus 4, that is 0. And it is inconsistent. If it is inconsistent, okay, then no solution. In gate 2022, you see direct question from my classroom, and in this case you will get always what? Infinitely many solutions. Okay. In this case, you can have unique solution. Okay, you can have unique solution. When you can have unique solution? When number of pivots are equal to number of unknowns. Okay. So that is very special. Okay, please keep in mind. But in this case, you will never get unique solution. I hope this makes sense, guys. So we will catch up later. Okay, and one of the information I just want to share, that I'm flying tomorrow by 4 a.m. in the morning to my hometown, right? There is some function, right? So I'll coming back. I will be in touch with you on our group. Okay. It was not possible to conduct on a session today, but I tried, because I promised, in the evening I will be, because I have to still pack up everything, and tomorrow morning I have to leave from my flat to airport, Bangalore airport, in the morning 4 a.m. right? So we'll catch up shortly, and CKM sir will be continuous taking your classes. Okay, so I will be coming back in next 3 to 4 days. Meanwhile, I will share the question now based on these concepts. Okay, so you guys can try. You guys can try PYQ as well. Okay, apply my concept always, right? You will never get a confusion. Try to find free variable. Try to apply back substitution as well. What is the meaning of back substitution? You have to again see, after getting echelon form, I mean elimination, after applying elimination, right? Okay, you have to follow back to back substitution, right? Back. What is the meaning of back substitution? Back substitution means write again system of linear equations. Okay, to determine the value of x1, x2, x3. Okay, from the reduced echelon form. From the echelon form, you have to again write the system of linear equation. How to write? I have told you. If there is a free variable, take alpha. If suppose there are two free variables, situation is like this. Let me tell you here. What this situation is there? 1, 2, 3, 4, 0, 0, 7, 8. Okay, 0, 0, 8, 9, 0, 0, okay, and 0. You can say this is also 0 here. This is how many variables are there? I mean, how many three variables are there here? You see, this guy has a column, I mean pivot 1. This guy has a pivot. Okay, so there are two. You can say this is x1, this is x2, this is x3, this is x4. So x1 and x3 are the dependent variables. Okay, and x2 and x4 are the free variables. Now what you have to do? You have to take x2 equal to alpha, x4 equal to beta. Now you can write everything. From this you can say x3, 8x3 plus 9x4 equal to something, suppose 9 is there. Here also 1, 2, 3, something is there, right? Like this. Okay. So you can apply, you can get. I think this makes sense. Yeah. Yes. So I have to leave early. Okay. So that was the reason, as I love teaching, and I'm very crazy about teaching, so, and I want to share everything in next 200 days with you guys. All the subjects I will be discussing, not only mathematics. I will be discussing all the subject, okay, and I will be recording all the sessions which you can watch, you can play, attack, okay. There will not be any kind of hangama kind of thing. I will be simply discussing the concept. If you like it, enjoy, okay. And I don't want anything at this moment, just I want from you the rank of you, right, not the rank of the matrix. I want your rank. ठीक है, तो we will meet tomorrow, and please write your feedback. I mean, write your how like how was the session in the comment box, okay, after the session, right? Then I will get to know what you want, what kind of feedback, okay, so that I will be improvising, okay. And these sessions are private, okay, so you only can watch. Thank you guys, okay. If you have any doubt, please ask, otherwise we will bind up the session. Hers, everything is okay now? Okay, so we have to just leave for the, okay, that's why I'm winding here. Thank you. Yes, so you will be learning everything, don't worry. I will be bringing great concepts, not only math. I'm gonna bring all the subjects, don't worry, all 9 subjects I will be touching. Yeah, thank you, take care.